Now I'm going to show you some real world examples. So use example how users worldwide, and mainly because I'm based in Australia and New Zealand, how they use the data. What I'm going to do is I'm going to show everything in an application that's ContextCapture Viewer. So there's a free application, it's a free viewer. And what you can do, you can download it from the bentley.com/eyewear. You can download it and use it as a free application. It also comes if you install ContextCapture, it comes with it. So I'm gonna go out of my presentation and I go back to my viewer. So the ContextCapture viewer itself, so this is a view where you can not only open meshes, but also other formats, not only the ContextCapture output, but also OBJ, FBX files. And what we can do in this viewer, we can do measurements. So we can do coordinates. So if you know the coordinate system, and this is in Australia, so I can set UTM zone. I can select a coordinate. I can do distance. So if I know a certain object, I can do measure distances. And also I can do surfaces. So if I want to know how big this is, I can do something like this. And we can do volumes. And this, I don't have the best example here, I guess, but yeah, if you want to do a volume, you can set a plane. And you can do something like this. So I know the volume of this object, of this tower, to this plane. And you can also set a custom plane if you want to say certain, let's say I want to do 50 meters, you get as a plane fit. So this is, of course, we have also applications where we can really do comparing volumes with each other, but it's more desktop application. In the view, you can already do quite a lot. And also what you can do is in here changing display styles. So if this is my full model, I can put it in wireframe with a W, texture with T. So I can do with a shortcut. So basically if I go to my mesh, so this is what we captured. So this is an Mavic Pro 2. So this is a really small drone, an entry-level drone. And this is the result of the data. So this is a university, and this is basically the first flight of this user. So we capture something like this. So this is all about which pattern you capture with an overlap, distance to the object, and what camera you're using. So you're concentrating. You see there are some issues, of course, that we didn't capture everything, but in general, it went quite low. You can see over here. But yeah, things like this, for example, if you see holes in here, that's because you don't capture data. So it's important that you capture the right data. You can only model what you see, and that's sometimes what users keep forgetting, that if you get holes, for example, that's because you can't see. And the same, for example, here. Later we're gonna go in a little bit about the challenges of working with photogrammetry. For example, glass is an issue. You see here a little bit the issues of the glass. So this is a 20 megapixel camera, couple hundred images. I think was 2 or 3 battery lives of a drone. Get something like this. Let me close this one and I go to some other types of data sets. So this was a cheaper entry level drone. This is more on a 42 megapixel camera. So this is a government agency in near Sydney, New South Wales. So they this is near Sydney. So they do brick detection. So they brick replacement. So what they need to do, they did really a high accurate model where they can do inspections of site of bricks needs replacement, and also for the scaling is really important. So they use a 42 megapixel camera, and yeah, they do really a good capture. So you see here a little bit from what they, even underneath what they capture. And you can do inspections, and you want to replace a rock break, you can already measure in here and prepare it before you go on site. So they use a lot of ground control points to really reference, and scaling it really perfect. So this is like from a cheap drone to a high-end drone. So everything is possible as long as you adjust your capture technique and the cameras you're gonna use. You can also doing stuff with an just with a handheld camera. So for example, this is an object where we just walked around with a handheld camera and shooting. This is a training tower from the fire rescue department. We just walked around and you shoot just images with a handheld camera. So there's no drone. So you see a big hole in the model here. This is near the airport, so we can't fly with the drones here. So, and there are different techniques to do handheld stuff, but yeah, this is a nice example. So this is a little bit on the buildings. We can do bridges. So for example, let me check which one. This is also with a Mavic Pro 2. So the user should a bridge, and we capture, yeah, for inspection purposes. So it's loading, so you get something there. So he wants to inspect parts of the bridge and also part under the bridge here. So yeah, quite good model, I guess, for just a Mavic Pro 2. So bridges, and then is a special way of capture. Later when we go in the capture technique, we're gonna explain a little bit how difficult basically capturing bridges is. But yeah, this is a quite good model, came out really well. Cell towers, so that's something that a lot of users are using it for. So this is a simple example. This is with a Phantom 4. And again, this is a different capture technique again. So doing cell towers is quite challenging because we have a lot of tiny, shiny objects here. But you see with a Phantom, with a special capture technique, we can get the results like this. So things like this for inspection, bird nest, rust detection is this. And the big advantage is that they don't have to shut down the tower. Nobody has to climb up. So get something like this. Cell towers, but we are also doing towers like this. And this is more challenging because they are guided. There's a lot of lines here, so you can't fly as you like. So you have to adjust your capture technique. But we can get something like this. So just some of the examples how users in this industry are using it. But we can also do whole cities. So for example, this is an helicopter model. You see, this is a model user just sit in a helicopter, hangs out of the window and shoot with an, I think it is this one is done with a 35 megapixel camera. So you get a reasonable good quality. They can do better now. Nowadays they're using 80 megapixel cameras and with a little bit more overlap than here, but yeah, reasonable. So this is a cleaned up model. So the original model has a lot of cars in here and other objects that is all cleaned. So if this is the Adelaide Hospital, so you see the quality what they get from the helicopter. Something like this. So the reason that they use a helicopter mainly in Australia is because they get easy access to flying. So drones can be an issue, especially if it's out of sight, and that's why they're using, for example, helicopters. If you can fly with a drone, you can have things like with a camera rig. So this is a multi-camera system. So this is 5 cameras on a drone. So when they fly, they automatically shoot also not only straight down, but left, right, forward, backward. And where you can get something like this. So this is 5 24 megapixel cameras, and they're flying around 100 meters high. And yeah, if you then see the result. The big advantage of using camera rigs for city modeling is that you don't have issues with colors, with shading. If you fly with a normal drone, you fly up and down at different angles. Gonna take you hours to capture it, and then yeah, you can have issues with shading. But this is a model in China that I get from one of our partners. He gives this data set and looks reasonable. Okay, I guess. So this is an normal drone, DJI M600, I think, with the camera rig underneath it. So yeah, to give you an idea, I think the processing on my laptop was like 3 days, 2.5 days processing. So it goes reasonable quick. I got more of these examples, but for example, and it's all about what quality are you after. So this is, we worked on a project with a user here in Oman, but they're flying much higher, and they have a fixed wing drone, so they cover way larger areas, but they're flying around 380 meters, 400 meters high, and with a fixed wing drone, so they fly faster. So that's why they otherwise the camera can't keep up with the speed. So it's also reasonable, okay, I guess, considering they're flying so high. So everybody wants the other quality of the model, but yeah, considering time gaps and then yeah, it's also just more expensive because you process longer. It's more data to capture. Yeah, so there's something like this. So this is city modeling just from drone. If you go here, this is a user in Australia, and they fly models in Australia, but also in the US. So let me pick up New York. So this is done with a plane. So they fly 8,000 feet high, and they have like a special sweeping camera, their own camera. So this is New York. To prove that I'm in New York, I can go here. New York, and because they fly really high, they can do, I think they capture and process 1,000 square kilometer per day. So you can't, and the quality of the model is, yeah, it's okay, but you can't compare it to a drone model. So that's important to understand, that basically everything is possible as long as you put the time and effort in it. And it's, yeah, probably the use case for this type of models is not inspection, so you don't need to go yeah, on the centimeter level. And of course, we can merge data sets. So we can fly with a plane, go back with a drone, get more detail, and even with a handheld camera, and then merge the data sets together, so you can get something like this. But this is, yeah, this is pure plane models. One of the big use cases, of course, is mining. So, and not only for doing volume, stockpile volumes, but also for inspections. For example, when they have accidents. Let's see if I'm in the right model here. So this is an example from in Australia where something happened here with the rock came down while they're doing stuff like this. So then with other software from Bentley, Plexus or Solvision, they can calculate angles of objects and see how stable it is. And in this case, something happened, so they capture a model and start recalculating it to avoid that it happens also in other parts of the mine. And yes, something like this. There's more on the geotechnical stuff, and of course we do this for volumetrics also, and overlay mine design, for example, on your mine model. But let's see this one. But we can also just, this is like drone data sets and a plane data set. We can also do with a handheld camera. So this is, for example, with the iPhone, what I did. So if I go to this model, this is just with a phone, 50 or 60 images where you can create models like this. The reason that is really good because the distance to the object is really like maybe 2 meters or something like that, really close, and you get a higher resolution model even from things like a phone. So you don't have to have always high equipment. Of course, that is sometimes better, but we can do stuff like this. If I, let me check. So another industry where we see a lot of usage for this reality modeling is on industry, on plant sites, where users doing more for the asset inspection and quick build up a map of your plant site. So this is, for example, on something. This is a plant site in Australia, uranium plant, where we used a drone data set. So this is the drone capture. So if I go here, this is all from the drone. So in most cases, this quality is good enough, but in some cases he wants to see build up a digital twin. So this is, I think, 3 days driving with a truck from Adelaide. So what they want to do, if they go on site, they want to bring the right equipment if there are issues. So what they want to do, they want to, in the office, zoom in on something like this on the pump and see more details. So see this number. So this is a combination of a drone data set with a handheld data set. So we took a handheld camera, we shoot images around here, we merge the data sets together and start processing. So you get something like, where you can read these numbers. It's a little bit difficult. So this is something what we see more and more that users are doing in the oil and gas areas. Yeah, it's quite common that users start using this type of models. I'll show another one. So this is another plant site where we use something like this, or the user capture. This is with a 42 megapixel camera, just handheld camera, just walking around, shooting in a certain order, certain angles, and you can get something like this. One of the things they do this for, because they write down a lot of with on the pipes, and that's something that, for example, on point cloud scanner doesn't pick up this writing. So they do this with this kind of handheld cameras. And another example, what this one is an 61 megapixel camera. You can do this with lower cameras, but lower resolution. But the advantage is you see so much data that if you walk around one time, you can probably capture everything instead of doing a lot of images. What is my good data set? So this is something like this. And because you don't have any GPS on the image, it's quite important that you do, of course, a good georeferencing. So you need control points all over this area to georeference the model to these coordinates. to the georeference model. And otherwise, this model is not even scaled; it's just captured, and that's it. Yeah, so there's some use cases on the plant side. Another big user from us is the police. So what they use context capture for is, for example, for crash scenes. So if there is an accident, they fly with a drone. For example, this is a fake. This is training the pilots. So you get something like this. We capture, I don't know, was less than one battery life, and you get something like this. And because we use the GPS of the drone, its model is really scaled well and also georeferenced correctly. So one of the things that we're gonna discuss in a minute is the capture technique. So one of the issues we have with capture is objects who are moving. So if an object is captured in 3 images, then it will be modeled. So you see here the 2 drone pilots standing here, and they are not moving. So they are looking at the device. This model is really reasonable, okay. But then you see the supervisor is moving, and me and I'm walking up and down, and my colleague with the red trousers is standing here. Because we are moving too much, we're not in the model at all. So there are things that we can remove from the model if you really want that. So you can do a little bit before you start processing and also after the processing. Another thing is, when we captured this car, we have these 2 cars, we shoot a lot of images a little bit lower under an angle. So we're shooting like this, and even some of them, if you see how low it is, something like this. And we did one big flight really high on the top. So this car is captured from this side. So this looks okay. You see here, reasonable, okay. But the other side of the car, this side, is only captured from the top. And then you see something like this. So it's all about which capture technique you're using and what your focus areas is. In this case, we didn't really care about this car, it's more these 2 cars. Yeah, so the police is using it also for forensics, for other crime scenes and counter-terrorism and that kind of stuff. That's something I can't show, of course. And another use case is for rail users. So we have a lot of rail users who are using this. So one of the things is for rail crossings removers. So this is an not safe crossing. So they are removing this kind of objects. Captured, I think, with a Phantom 4. And this user is shooting down, but also a little bit under an angle. So you're seeing a model like this. It's all about if you are allowed to fly on top of the rail. So this is the rail user, the owner of the rail. So they can, if there is no train, they can fly on top of it. So you can get something like this. Reasonable good quality. But if you're not allowed to fly on top of the rail, so this is, for example, for a construction. I have to check which one this is. That's this one, I think. So this case, we're not allowed to fly on top of the rail. So we have to adjust the capture technique. And yeah, you get a little bit different type of quality. But yeah, it's still sufficient enough for the new design for rail crossing removing. Check the time. So this is a little bit the examples that I want to show, and we can also process, and that's an important also point cloud. This I've almost forgot to show, but sometimes with photogrammetry, you can have issues. For example, inside. So this is a storage room, what I did for a user. So this is the photogrammetry model only. And then you see right away, there are some holes in the model. So here on the right side, this is plain white area. It's really hard for the software to stitch images together and produce a model. But in general, it's quite complete model. Looks okay. But you see also the geometry is not that great, a little bit bubbly, and over here also. So what we did here, we also captured this data with a point cloud. So if I go, leave this one open, I can go to a model point cloud only. So I process the, just import a point cloud and start processing. There's nothing else you need to do, it's quite easy. So what you see is a really good geometry. So the wall is quite good. This is also really good, but you see that the doorknob didn't pick up. The model is not so complete. You're missing all kind of gaps. So there's a black thing here you miss. And on this side, yeah, it looks okay, the geometry, but you miss a lot of areas. Well, this areas was in the photogrammetry model. It's more complete, but you miss some stuff here. So the railing here, it didn't pick up everything. But what if you then can combine them? So we merge them together, and then what the software does, if there is no geometry from the, if we use the geometry from the point cloud and the texture from the photogrammetry. So you get a complete model with a good geometry, but then you see the doorknob is there, the black thing is there. And if I go to this side, yeah, it's more complete now. And that's something what we see that often our users are using this inside buildings if they want to capture something like this, or really difficult objects. Then you can shiny objects, and then they can use point cloud and photogrammetry and combine it. Of course, we can also process point cloud themselves. So I already show one of the model, but we can also do stuff like from a mobile scanner, for example. So this is a mobile scanner on top of a car, and they drive and capture objects like this. So this is point cloud only, it's no photogrammetry. You see a lot of these cars that should be removed from the point cloud before you start processing if you want to have a really nice model. But we can also do from video. So sometimes where users are doing, this is a good example. This ground penetration radar. So the user, you see here, they do using ground penetration radar, and they mark on the road where the pipes are. You see here some objects. And in traditional, what they used to do after they did this, they go in with a total station and capture all these points. So the geo-referencing it, and then they capture the lines, and then they put it on the map. So what they do now, they give the people who do the ground penetration radar, they use a video. You can have a GoPro, or you can have of just from the phone or iPad. The main thing that you think about, that you have some of them, points geo-reference. You need some common points where you can geo-reference the model, but then you can put it in context capture, and I hope this is the right one. You can get something like this. So if the geo-references, they can just put it on the map, and they have, this is way cheap and easier to process. They get a survey team in with a total station and measure it.